Okay, guys, welcome back to another week. So here we are, we're in week 3, and according to the syllabus, what we will be doing this week is we'll be finishing off SQL and getting into advanced SQL as well. I have every reason to believe that we will finish that off. I don't want to move too fast because, again, SQL is because it is the language that we use to interact with the database. I don't want to just zoom through it, right? I don't want to just get through it really fast and get done with it. What I want to do is I want to make sure that we go through it in a way that you really have a good foundation of how to use SQL to be able to both retrieve data from the database, manipulate data in the database, and what we'll get into with what it's called advanced SQL, but it's really, I guess more accurately, we would call it the data definition language of the SQL. And so it is what we use to be able to create and manipulate the structure itself. So create the tables, change the tables, not the data inside the tables. So one thing I want to make sure that I reinforce here is there's two parts of what we're doing here when we deal with database stuff. When we deal with database design, when we deal with database manipulation, is there's the structure where we are defining columns are there, what are some of the restrictions on the columns, what tables are there, and how we want to organize the different items of our database. Then there's also the data inside. Okay, so you can have a table, a structure. You can have a table that has no data, and that's okay. There's no problem with that. The database doesn't blow up. The database doesn't have any problems with that. But ideally what you'll have is if you have a table, you want to put stuff in there. Okay, there's no specifics about how many rows a table should have, must have. There's nothing like that. Okay, there is one special table though in some database schemas. So there's if anybody's ever worked with Oracle, there is a table called dual that Oracle uses for the purposes of kind of special purposes, but I won't get into that too much. But okay, let's go ahead and continue on with our SQL discussion. There we go. Okay, let's see. But first, all right, our quote of the day is brought to us by a very, very wise person indeed, or I guess not a person, but a whatever species he is. But he tells us, Jedi Master Yoda tells us that you must unlearn what you have learned. So the reason why I like using this quote in the database lecture and the database discussion is because up until this point, pretty much everything you've done, pretty much all the coding you've done, Java, whether it be Java, Python, C, it's mostly entirely been sequential programming. It's been you have to have the sequences right? So line 1, then line 2, and so forth, right? And what gets executed in order. SQL doesn't entirely work that way. Order doesn't really matter. Right? Order doesn't really matter which column comes first, which table comes first in a SQL query and stuff like that. The SQL query itself gets run as a unit. Okay, so it doesn't matter. Now there are some formatting issues, like you have select, as we talked about last week. You have select, then from, then where, and so forth like that. There is some structure that needs to be followed. But for the most part, the whole thing gets run as a unit. Okay, and one thing that this reminds me of too, you'll hear me say a lot in this course, is you'll hear me say, let the database do the database things, and let the user interface or the client side or the GUI, whatever. Let the source code, let that do the source code things. Okay, and you'll hear me say that a lot because one of the big things that people in programming, people who have a programming background, when they first start doing database, one thing that they often do is they get that mixed up. They go out to the database and they get all the records, and then they put them all into a big array list or an array or something like that, and then they try to loop through the array to figure out what to do with the records they get back. When what they find is what would have been much more efficient would have been to limit which rows come back from the database in the first place. And I have plenty of industry examples of that, of where we did not let the database do the database things, and it cost us efficiency. Okay, so but one thing about databases is it's different. It's different from the sequential programming, the procedural programming that you're used to. Okay. So make sure that you don't just think, oh, I'm going to do database programming the same way that I've always done sequential programming, because you're going to have to learn how to let the database do the database things. All right. Let's see. So we ended off on this aggregates stuff. I do want to go ahead and review that a little bit because, again, it is an important part of what we're going to get into next when we get into group by. If I remember correctly, and if I'm wrong, somebody please correct me. We did not get into group by last week. That's where I ended. That's where I said I didn't want to get into that because it was a next level thing. So, but we did get to aggregates. We did talk about some of this, the count, sum, and average, min, and max. All right. Okay. So we can, again, count how many rows will come back in a certain situation. Again, one thing I said that you'll use a lot of will be select count star from table to find out how many rows are in a table, or select count star from table where a certain condition is true, so that you get a an idea. So you get a count of how many rows satisfy a certain criteria. Right? That's something that you'll use a lot of. Okay. Especially where this really comes into play, where I've used it the most, is when we're doing something with the user interface and we're expecting, like, we're searching for something and we're expecting for 10 rows to come back. We're expecting 10, let's say if we were doing a shopping website and you did a certain filter and you expected something like 10 rows to come back, and instead 15 come, or 20 come, or 5 come, some weird number that we're not expecting. Then what we'll do is we'll run a select count star from the table where a certain condition is true, and we'll see, well, how many rows are coming back from this table, and so that we can get an idea of, well, why is that coming back with more than we would expect it to? Okay, so that's a useful query to get, kind of just put that in your toolbox. All right. Now, one of the thing about aggregate functions is what we'll get into with this example here is we can't run this as it is, but we could put it as part of a group by. Okay, and we'll look at an example of group by in just a moment. Okay, we already talked about the count star. All right, we talked about count distinct, where if we wanted to get how many different properties were viewed in May 2013, and then we get our answer there, how many rows. Now that doesn't mean that that's how many times a property, it doesn't mean how many times any properties were viewed. It's just how many different properties were viewed. So if we look back at the previous query, not that one. I guess we don't have an example of this without the distinct. But if we didn't have that distinct keyword, if we didn't have this distinct word in there, what would happen is we would just count how many count the number of property number rows, like rows that have property number not null, from the viewing table between these dates. This could be 200. This could be 1,000. This could be 2. It could be 2. But what we're getting, because we put the distinct keyword, is that if one property was viewed 20 times and one other property was viewed 2 times, we still only get 2 because that's just the distinct property numbers. Okay. All right. We talked about being able to put min, max, and average. Now we can put these together in a query, right? We can put these together in a query because there's no other column here. Okay, if we put another column here, as we're going to see in a moment, we need to have that group by down here, and we'll see what that does. Okay, but here we can have multiple aggregate functions as part of our select criteria on a single table like this. Okay, so we're getting the min, the max, and the average of this particular column, the salary column. Okay. Now, aggregate functions, they can be pretty fun and pretty powerful to be able to do some things with, but really where we use them the most often, I would say, is when we do group bys. And the group by, if we think about it, is it's kind of like trying to say, okay, I want a distinct set of some columns, but I want to, within that grouping, within that distinct type set of columns, I want to have some knowledge about another column of all those that fit that criteria. Okay, let's just look at an example. Okay, so here we have select branch number, count of staff number as my count, sum of salary as my sum. Okay, now what that means is, and then we're getting that from the staff table, and we're grouping by branch number. Notice we have to include in the group by here. We have to include group by as part using the column that was the single column, the non-aggregate function column. All right. Now the order by is optional. We don't have to have it. I can tell you that some database systems, the one that I got the most experience on, Oracle, does the ordering by on its own. So if I were to run this, and if I could cover it up with my hand, but unfortunately you can't see that I covered it up. But if I were to take this order by off and run this query in an Oracle system, it would automatically order by the branch number. Okay. All right. But here, notice what's happening. So if we think of it as take any columns that are not part of the aggregate functions, any of these columns like branch number, and if we just looked at just that column, just that set of columns from the rows returned, okay, it's like this is like a select distinct branch number. Notice that we only have each individual branch number appearing once. And then what it's doing is within the branch number, is it saying, okay, I want to count staff numbers, count how many within that branch number, all the rows that have this branch number, how many of them have non-null values for staff number. Okay. So what this is telling me is this row is telling me how many staff people work at each branch. Okay, that is the real world meaning of what this query is telling me. What the query itself is doing is it's simply saying, okay, for all rows that have branch number B003, how many of them have not a non-null value in the staff number column? Okay, so we get 3 for this one, 2 for this one, 1 for this one. Okay. Notice this doesn't tell me what staff numbers are there. It doesn't tell me anything about the staff themselves. It just tells me how many rows have B003 and a non-null staff number. Then the sum of the salary tells me, takes the rows that have B003 as the branch number and adds up all of the takes all those rows, the 3 rows, and takes the salary values and sums them up, adds them together. Same thing with B005, same thing with B007. Now notice I can tell you what the average salary for branch B003 is, right? I can tell you what the average salary for B005 is. I could tell you what the average salary for B007. An extra thing I can give you from the B007 is I can also tell you what that one person's salary is, right? If I know who that person is, then I know what their salary is. But I don't know individual salary values for the other two. Right? The only thing I know is that B005, if we add up all their salaries together, we get 39,000. B003, if we add up all their salaries together, we get 54,000. That's all I know. Okay. The only reason I know that the one person at B007, their salary is 9,000 is because there's only one of them. Okay. So this is how we use that group by. Again, we look at it as it's one way we can look at it is the columns that are not part of the aggregate functions become like a select distinct. The columns that are part of the aggregate functions, we just say within that group, do something with that. And it can be anything. It can be count to count how many rows there are. It could be sum to add up a column in that group. It could be max, min, average to determine, okay, who's the max? Who's the highest paid person at B003? We could do max instead of sum. Who's the lowest paid person at B003? We could do min instead of sum here. We could do average salary, and what we should get, is whatever this divided by this is. That's what we would expect to see. Okay, so that's how we use group by. Now the question you might ask is, okay, well, what if I wanted to know all the branches that have 2 or more employees? Okay, so I don't want B007. It only has the one person. I don't want that. I want to know who has 2 or more employees, 2 or more staff numbers there. Okay. Now you might be tempted to think, oh, that sounds like a condition, so it must be a where clause thing. So what I need to do is I need to add to here from staff where count is greater than or equal to 2. Okay. And that might be tempting to think that way, that because it sounds like a condition, it must go in the where clause. But when we deal with group bys, we can't put that in the where clause. The where clause is a condition that's intended to restrict the rows that are returned for processing. So basically, this is going to go out and get, all right, so select branch number. Forget about these other two for just a moment. Select branch number from staff. There's no where clause. It's going to get all of the rows from the staff table. The where clause will just limit what rows get returned in the initial query, in the initial result set. The group by, okay, tells me that I want to do something based on the group of rows that all share this value in branch number. Which means that if we want to say, I only want a certain, final rows that are returned that match a certain criteria based on the aggregate function, there's another special section that we'll have here, and it's called the having clause. Okay, so it's similar to where, because it is based on a condition, but it's like the where clause for the results of the group by. Okay, so we can have, so what we would say is group by whatever, having my count, or having count staff greater than or equal to 2. Okay, so if we look at it like this here, Okay, or greater than 1. You can also do greater than 1. All right. So here, if we wanted to get only the ones that have 2 or more, we don't put a where clause in there. We have a having clause. Having count staff number greater than 1. Okay. All right. Okay. Now, where a real powerful thing with SQL can come into play is what's called the subquery. Now, we can use subqueries to be able to get some data and then based on that return data, do some stuff with that. And let me give you an example of something we might do. Is we might say, I want to know all the staff. I want to know the staff names of people who work at branches that are in London. Okay. Now, what I've seen, the way I've seen this done is something similar to this. Would be, oh, I'm going to run a query to get all the branches that are in London, and then I'm going to return that back to my client, to my code, to my Java or Python or whatever. And then I'm going to take those branch numbers, put them into an array or whatever, and then I'm going to go back to the database and I'm going to say, okay, give me all the staff people who work at one of these branch numbers. Okay. And that would be a very clear example of something I just said a little while ago. That would be a very clear example of not letting the database do the database things. All right. And the reason why is because what we really want is we only really want the staff numbers, right? We don't care what the branch numbers themselves are, right? We just want the staff, well, not numbers, staff names. We really just want the staff information. What we would like to do is we would like to be able to send a query. We'd like to be able to send a query to the database that basically says London, right? I want to send you London. You do all the stuff that requires, finding out branch numbers and all that. You just figure out who the staff people are and you send me that back. All right. In fact, let me go ahead and I'm going to pull up the whiteboard so I can show you how this works. Okay. Show you visually how this works. Oh, I should have drawn some stuff on here first, but whatever. All right. Let's do green for database. Okay, so the way we normally will draw a database. Okay, a database is normally going to look like this in diagrams. Okay, and it's a very poorly drawn database, but you guys are used to my bad drawing by now. All right, and this. This will be our user interface. Looks like a little computer, right? Okay. Now, what we could do is we could say, okay, I'm going to say I want to get all the staff people that are from London, right? And our user writes, I want all the London staff, right? And what we could do is we could send to the database a request for give me all the branches that are in London. Right, and then the database sends back the branches. Okay. And then we could have our user interface store this branch list it gets back, store this branch list into like an array or an array list structure, something like that. And then it could say, okay, now I'm going to send another query. I'm going to send another group of queries that say, give me all the staff people that are in those branches. Right. And if we've really poorly designed this, then what's going to happen is we're going to one by one, they're going to get a list of branches. Like we'll look at a list of 10 branches, and each one for branch 1, give me a list of staff. For branch 2, give me a list of staff. For branch 3, give me a list. Oh, goodness. Okay. And then our database will say, oh, you want the staff for that branch? Sure. Okay. I'll give you that staff person. Now, the reason why this is a bad solution, the reason why this is, well, I don't like using the word bad, but inefficient. We'll say inefficient, which, let's be honest, these days, anything that's slow is bad. Okay. The reason why this is an inefficient solution is, for one thing, we are using our user interface to kind of process through the branch list, which no one cares about, right? Our user didn't ask for the branch list. Our user just said, what? I want the staff. Right? The user said, I want the staff in this city. I don't care what the branch numbers are. Right? So for one thing, we're using our user interface to process through information that our user did not ask for. Okay, so that's one problem. Two, there's also a lot of network activity going on here, right? Every request to the database and every return uses bandwidth, right? This is a computer on the network. This is a database on a database server. We're sending information here, sending information back, sending information here, sending information back. What we would like to do as much as possible is get rid of any unnecessary network traffic. All right. So what we do is instead we rewrite our query. We say, okay, what I want you to do is I want you to give me all the staff people who work at branches in London. And hopefully, if we've done our query correctly and efficiently, then what happens is they just send us back the staff. So the only thing we send them one query saying, give me staff in London. And our database sends us back one result set that is just the staff. Okay. All right. So let's take a look at how that can be done using subqueries. That's fine. Okay. All right. So here in this example that they've put in the slides here, it's not that they've said where the branch city is London. They've said where the street, given a specific street address. Okay. Now what happens is this whole query gets sent to the database. The database does all the work of figuring out what the branch number is, and then also putting that into this other query to get this information about who the staff person is. Okay. So basically what happens is the database runs this subquery to figure out what the branch number is. Then the database substitutes that value into this outer query to determine what staff people are at that branch number. Okay. So if we look at it like this, the inner select finds the branch number, B003. It then places that value into the outer query, the equals on the other side of the equals line of the outer query, and runs this query instead on its own. And the database does all this. None of this branch number, the user interface never sees this value, never sees B003. The only thing the user interface gets is this right here. Okay. All right. So the user interface sends a query over there, says, show me all the staff in London. Database does all the work, gets these three rows as a result, sends those back to our user interface, drastically reducing the amount of network traffic and also not making our user interface do work that it shouldn't have to do. Okay. I'm assuming that, like me, you guys don't like doing work that you don't have to do. So why should we don't make your user interface do work that it doesn't have to do? Okay. All right. Another example, a subquery with an aggregate. So here, there's a couple of different aggregates here, a couple of different aggregate functions here. All right. So we're going to list all the staff whose salary is greater than the average salary, and we're going to say how much greater than the average salary is it. Okay. So here we're getting some basic column information, staff number, first name, last name, position. Then their salary minus whatever the average salary is from the staff table. And then from the staff where salary is greater than the average salary from the staff table. So now the subquery can be part of a where clause. Okay. So basically, if we say, okay, what's the average salary? Let's say the average salary is 17,000. Then basically we're going to get back a result that is anybody who has a salary greater than 17,000, and we're going to see what their salary, how much more salary they get than 17,000. You could, no, because since it's an average, since it's an aggregate function, that would be a group by, right? We can't use an aggregate function with a group by. I'm sorry, we must use a group by with an aggregate function. Okay. Now notice in the results set, we don't see what the average salary is. Remember, this is information that is all calculated and done on the database side. The user never sees what the average salary is. In this particular example, the only thing we get is information that is greater than, how much greater than the average salary does this person get paid? Okay. We can have a subquery as part of this that would tell us what the average salary is, but that would just be an additional part over here we'd have to do. Okay, and actually SQL has advanced to where we can do that as a separate column, and I'll show you that tomorrow when we go through the examples. Okay. Again, one thing is today we're only going to be going through slides. Tomorrow we'll finish off these slides and go through some examples. Okay. Some subquery rules here. Okay. Also, one thing you'll see here on the next slide is we can have multiple nested subqueries. Okay. So let's take a look at this example. We want to list all of the properties that are handled by a staff person that works at this Main Street. Imagine that just means, I guess Main Street is in Glasgow is my assumption. So let's say that's just the branch in Glasgow based on the data that we've seen so far. Okay. So here, what do we need to get? We need to figure out who works at this, but we don't know the staff based on the street address of the branch. That's stored in the branch table, not the staff table. Okay, so we'll need to get the branch number. Okay, so we get the branch number from the branch table for this street address. Then we need to get the staff who are at that branch number. So we have a query that uses this subquery to get the list of staff. Then the list of staff is used from the property for rent table to determine who's managing it, okay, who's handling that particular property. Okay. Now, one thing you may notice, some of you may have seen here, Hojam, why is Why do we have n here and equals here? Can't we just do equals here? And the answer to that is unfortunately no. That in this particular query, you would not be able to put an equals here unless you knew for certain that this would return one and only one row. Okay. So equals is for if it is a specific value. So here, this subquery, I want the branch number with this street address. I know for certain that will be only one branch number. Not a list of branch numbers, not 0 branch numbers. It will be a single branch number. So therefore, because it can be only one, I can now put an equal sign here because it's a single value. Right? But if I might have more than one result return, so in this case, staff, the staff number, I might end up with 2 staff, 3 staff, 4 staff that work at this branch number, right? Well, in that case, I need to say if the staff number is in that list. Because it doesn't equal that list, it's in that set, that list or that set, whatever word you want to use. Okay. By the way, this for me, the way that I normally do this, is I don't put equals unless there's some reason that I know for certain that this will only be one result. So I would honestly have written this branch number in a subquery as well. Okay, I don't like using equals with subqueries because too often the subquery may return more than one row. I would use equals if I expect one row and it needs to be one row. And if for some reason it gives me more than one row, then there's a problem. Like for example, if this query returned more than one row for a branch number at a specific address, then I would say, okay, there's something wrong with my query. Okay, we'll get to joins in just a moment, Nisa Julia. Okay, but yes, you are correct that this query could have been done using joins as well. We'll get to that. All right, a couple of other examples here, any and all. Okay, so any can be used with subqueries, all right, to be any of these values. If it's greater than any of these values or greater than all of these values. I don't see any and all used much, but I do want to go ahead and at least give you an example here. So here, I want to find the staff whose salary is larger than the salary of at least one member of the staff at a certain branch. So what this is saying is you could have done any or some here. So the subquery is going to give me a list of all the salaries. All right, it's going to give me a list of all the salaries at B003. And I want a salary that's greater than some value in here. If it's greater than any of the values in here, then I want to get that as a result. Okay. So basically, I get anybody. So if the salary, the inner query produces a set 12,000, 18,000, 24,000, right? An outer query says greater than any of the values in the set. So is this greater than any of the values here? Yes. Is this greater than any of the values here? Yes. Is this greater than any of the values here? Yes. Okay. So the other way that we could have written this was we could have said what? We could have said, give me the staff information from staff where their salary is greater than the minimum salary from staff, right? We don't need it to, we don't need to say where it's greater than some value. We want it to be greater than the minimum value. Right, that would have also given us the same result. And might be a little bit more readable as well. Here, if we say I want staff information from the staff table, where their salary is greater than all values from the staff at branch B003. Well, remember what our values were here: 12, 18, and 24,000. So it needs to be greater than, I need anything that's greater than 12,000, and it's greater than 18,000, and it's greater than 24,000. This is the only one that satisfies that criteria. We could have written this differently as where salary greater than, select max salary from staff, where branch number is B003. Right. Okay, again, may have been more readable, may have been more understandable. Okay. Yeah, this is in my opinion why any, some, and all are not used very much. In query writing.
Daddy,
no.
Where's the tablet?
Okay. All right. Okay. This is where Nisahuya you were getting to with us using joins, where we can have multiple tables, right? We can use the subqueries if the result columns come from the same table, but we might want to get some columns from some tables, other columns from other tables, right? So here in the subqueries we've given so far, the columns we wanted all came from the same table. So we wanted everything from the property for rent table, or we wanted everything from the staff table. We just wanted information based on some other tables, right? We wanted like staff, that wanted property for rent that's handled by staff who work at a certain branch. All right. But here, what if we wanted the property for rent and we wanted some branch information, the property for rent and the branch address, for example? Okay, so we can do that using multiple tables, you know, with a join. Okay. All right. And we can also use an alias for a table so that it can make it easier for us to type the queries. Okay, and we need to use the alias in order to tell which column it is if there's some ambiguity. Like if two tables have the same column name. So if we look at this example here, we want all the clients, their first name, their last name, the property number they viewed, and if they gave us a comment. Okay. Now, one thing that you're going to see is when we have two tables involved, we need to put a criteria in the where clause that tells us how to link them. Okay, because otherwise, what's going to happen is we'll end up with a cross product of all the columns from the one table cross producted with all the columns from the other table. All the rows. We'll get all of the rows from the one table and all of the rows from the other table in a cross product format. Okay. So basically, if we say I want all columns, let's say the client table had three rows, and the viewing table had 2 rows. Without this where clause part, we would get 6 rows, the 3 from the client table and every row of the client table matched with every row of the viewing table. By putting this where clause in here, this criteria, I want only the rows where the client number and the viewing number match, where the client number from the client table and the client number from the viewing table match, which means now instead of crossing those rows, instead of crossing those rows, I am now getting just the ones where there's a lineup, okay, where the two line up. Okay. So here, we only want the rows from both tables that have identical values in the client number column. Okay. So here, we got the client number, their first and last name, what property number they viewed, and if there was some comment. Okay. This is one way that you could write this join, okay, is to say, give me the two tables, comma separated, and connect them on this, where the client number equals the client number. Other possible ways to do the same thing would be from client, join the viewing table on this criteria. Okay. All right. You could also say from client join viewing using client number. That way, if there's a client number in the client table, a client number in the viewing table, then it's going to use that column and match them up. This requires that this second version requires that both the column in the first table and the second table be named the same thing. Okay. And then we can also have this natural join. That's if we've defined our tables with what's called referential integrity. If we've done a good job of defining the tables that way. Okay. I can tell you my personal experience is the order that these are given in, being the one here, followed by these three in this order. These are probably how frequently I've seen each of these versions. The one with list the tables out, then include the linking in the where clause is probably what I see most often. Okay, I have seen this on an occasion. In fact, if you have Microsoft Access, and if you make it, if you make Microsoft Access kind of write your queries for you based on like, this is what I want, this is what I want, doing the graphical interface for query development, this is how it's going to come out looking. Okay, I've almost never seen these other two versions, but they are possible. Okay. We'll do one more and then we'll take a break. All right, so here we're going to get everything from this. Okay, so we're going to get staff table and property for rent. We want the staff, the branch and staff numbers. Right. We want their names, and we want what properties they manage. Okay. So we get this information: branch number, staff number, first name, last name, property number, from these two tables. So the order, this is why this makes sense to me. We're saying this is what I want, all in one package together in the select part. In the from clause, we say, where am I getting everything from? In the where clause, we're saying this is how to link them. Okay. So, and then we're ordering by their branch number, then their staff number, then their property number. So if we look at that as the result, notice the branch number is ordered first. So 3 comes before 5, comes before 7. The staff number is ordered next. 14 comes before 37, but then we don't, comes before 41, does it? Why? Because this is a next grouping. Right? So these three are ordered now. And then finally, we order the property number last. So no matter what, SG14 was going to come before SG37. But within that group of SG37 staff number, the property numbers are ordered. Okay. And so we think about order by as being what we do after we get all the results. Okay. All right, so we're a little past due for the break, so we'll get back to business at 2:33, 2:34 in 10 minutes, where we will move on into 3. What if we want to do 3 tables? Crazy talk, right? Okay, we'll see what happens there when we come back in 10 minutes.